I don't know why I'm white here, but it's just how the exposure of the photo looks like.
I think it's
But this photo is also going to come into the picture, like slowly why all this is happening. So right now we're just going to go story mode. So for the story mode, I actually want to play music as well, because what's story mode without any music? So why is it playing?
No.
It's not playing.
No.
It's playing.
No. Yeah.
Yeah,
Interesting.
basically emotional, that's the thing. I wanted Akash also to be here, Akash and Starter, because I did something for him. Somebody introduce you to someone. So this is somebody that's an amazing builder, that's an amazing wannabe founder. So he spends all his day and night sitting and coding. He spends brainstorming on the best ideas possible. He wants to build the next future. So he comes up with an amazing idea. He wants to build the next finance application. But what does Akash do? For a finance application, what do you need? You need access to Web2 data. You need access to banking data. You need access to Venmo data. But guess what? Banks actually have no APIs. Venmo does not give you an API. Google Pay does not give you an API. So, and then he sits again. That idea is flop. He sits again. He does not give up. So right now he's going to sit so hard. He's going to think, and he gets the next best idea, which is to build a professional network. Now, to build a professional network like LinkedIn, you need access to what? To get users, you need access to what? You need access to LinkedIn data. You need access to Twitter. You need access to all of the other social networks. But guess what? They don't have APIs as well. So, what did we learn here? Other than the fact that Akash is fucked. But this music is getting very emotional. But it's really sold the story, no?
Yeah.
So, what did we learn here? There's all this valuable data that is out there. That is like, you feel like it's at the palm of your hands, but it's not at all accessible to you. So just for context, like if you are a developer, you just want like LinkedIn data, you have to reach out to them, you have to get an email, you have to reach out to them just to get an OAuth. Just to sign in, you have to get an OAuth. So much regulations that is there. It is absolutely bollocks that they're doing this as well. And imagine you spend all of your day, you guys booked an Uber to come here as well. You're giving a gold mine of data to big monopolies who will definitely find it useful. Because imagine a lot of you guys are familiar. We have Swiggy, right? So if Swiggy wanted to come and be like, hey, I want my best Zomato. I want people who are Zomato Gold customers. I want people who spend banking data. I want people who spend more than 5,000 a month on food. See, all this data that is so valuable that's already being sold out there, but you get absolutely nothing for it. So that's kind of the reason why our founders, Harsha, Maddie, who are also the founders of Questbook, kind of saw this problem there as well. So if you guys don't know, Questbook is a grant management platform where you can come, you can build, you can apply for grants, you can make money, you can be the next founder. So one problem that was seen here is the fact that a lot of people wanted to apply for grants, but they also wanted to remain anonymous. So the problem with being anonymous is they can claim whatever they want. But imagine claiming, so recently, just start the page, I posted a photo of me with Vitalik. I can literally go right now and apply for a grant, be anonymous and be like, hey, I work with Vitalik, I'm one of the founders of Ethereum Foundation, nobody is going to believe me. So there was that problem of being anonymous and also verifying these credentials, which is why Maddie and Harsha, they went to war. They wanted to figure out what technology can be built to kind of unlock this data for us. So that is how they built a technology that kind of allows you to get any data from any website in a permissionless manner. Because right now everything is permissioned. You cannot access any sort of data like this in a permissionless way. And this is what we've built. And I want you to read it again, because it's a technology with now you can get access to any data. You can now do data extraction on any website. All you have to do is make sure that data that you can get it from Reclaim is make sure you can see it with your eyes. That's it. As long as it's visible on a page, we can extract that data for you. And this technology received a very big buster. It's called as zkTLS. Once we get along with the video, you're going to understand why it's going to be a misnomer as well. And the correct phrase for it is going to be web proofs. But in this kind of whiteboarding session, I'm not going to focus on the zk part. I'm just going to introduce like a new term onto it and call it zkTLS, because at the end of the day, like no one cares about zk is just going to be a buzz term in the future, and what's really going to make something like this scalable is always going to be AI. So now we're just going to do a whiteboarding session. I'm going to show you how we do it in a more technical aspect, and I hope you guys leave understanding a lot more about encryption, what we do, TLS, handshake, all the buzz terms.
This was the email, by the way, that we got during books application. There was this research scientist that I have preferred to sit on university for 8 hours to separate my activity as a physical scientist from my activity in DeFi. He has personally received like $1 million in funding, and on that day he wrote, hopefully someday we'll have ZK proofs to reach the stage of maturity where I could prove the statements to you without doxing myself. This was a trigger point. Where, like, this is a great problem to solve in space. It's probably 3 years ago.
Okay, so to kind of understand this, thank you so much, Harsha. Also, till now is it good? You guys are understanding how this is fun. Let's go. I'm gonna sit down for this now. So when you kind of come into the space which is ZK, like there's a lot of buzz terms that's going to be thrown at you. You'll feel like it's intimidating, like how somebody else feels like when they enter into the Web3 space, decentralization, abstraction, ERC20 token, NFT, like too many buzz terms. So right now I'm just going to give you guys a very basic explainer on how you can be a ZK king in like 10 minutes. Guaranteed, you guys will be able to answer any high level question that's being answered to you. If not, just tell them ugly or fucked up. Cool? Cool. Okay, I'll tell you guys why like encryption came into place in the first place. Okay, so imagine there is somebody called as Karam or Dwick. Okay, so Dwick now wants to communicate with another person. He wants to communicate with the girl. So this girl that he really likes, he wants to communicate very secretly. Now how is he going to do that? So if he were to communicate normally, which is like this, he would just say a hello, and then, but the problem with here is that you can kind of have anybody kind of sit in the middle and kind of listen to this data. So Dwick saying an I love you, which is going to be a very sacred thing for Dwick, it's going to be seen by everybody in the world, right? And you don't want that to happen also. So this is why this entire technology is like very prominent in the first place, and the very fundamental basic of it is something called as a Caesar cipher. So this is guy Dwick. So what Dwick is going to do right now is Dwick and his girlfriend, they're going to meet in private in a dinner. So this is a closed space where only they are there. And what Dwick is going to do to his girlfriend, he's going to say like, hey, we are going to communicate in a small encrypted manner, and every letter I say, you have to increase it by 1. So if it is H, like if I wanted to say the letter H, it will be I. Like the encryption will be I. So he says that, so that's going to happen. So in this small area, no one can enter. So this is completely secluded from any other. This is a trusted environment where they can share any information. So right now, if you notice, there is an algorithm that is being shared. There is also a secret that's also being shared. But now what's going to happen is, now his girlfriend is going to travel along, like, to another country. Like we all know long distance sucks. And now Dwick is now going to send a message over to her saying, oh, what? I forgot my own algorithm. How does hello become? I want you guys to help me out as well.
F
M
M
P. IFMMP. So now Dwick is saying hello to his girlfriend, who is living very far away. And now what happens? Now anybody in the middle, like they have access to kind of this encrypted message, but can they resolve it? Can they kind of decrypt what's happening in the middle? Absolutely not, right? Because without the algorithm and the secret key, there's absolutely no way of doing it as well. So this is also kind of what happens in the regular internet as well. because you like every day we log on to something new. Like we log on to maybe like a bank portal. So whenever we log on to a bank portal, we want to make sure that whenever we log in, that none of this data is being seen by somebody else. That's what we want to make sure. So how this, like, you can't have a secret conversation with the bank in like a hotel room, just like how they did with his girlfriend. So there has to be like a very small, like there has to be like a cryptographic method of doing this, where both of them know this shared key without actually knowing, without actually anybody in the middle knowing it as well. So how that would work is, so you have one person here, you have another person here, and you have to make sure that they know the same thing, they have the same decryption key without anybody in the middle listening. Do you guys have any idea how it's going to be? Have you ever heard of this? Do you guys know from the claim protocol? Yes. Okay, so what's going to happen is both of these guys. So imagine this is the malicious guy. So this is going to be Harsha. Harsha is going to be a bad guy in this case. This is going to be a Reed, and this is going to be Ayush. Now Ayush wants to, Reed wants to connect with Ayush, and then they want to exchange some sort of data now. So now what's going to happen primarily is, all three of you guys, like Reed is going to propose like a random number. So I'm going to say number here, but it's more complex than that. It's going to be like a hash sequence. But just for the purpose of the example, we're going to say a number. So Reed is going to be just showing out a number now, which is going to be 20. And then that 20 is going to be sent across to Ayush. So right now, Ayush also knows 20, Reed also knows 20, and guess who also knows 20? Like, Harsha also knows 20. So now what's going to happen is Reed is now going to propose, he's going to have a private key of her own also. So she's going to have a number that is only specific to her, and Ayush is also going to have a number that's only specific to him. So this is a number that is only known to you, right? And now what's going to happen is, Reed is going to be adding both these numbers. So she's going to be sending 25 across to Ayush. I'll just mark it as clean. And what is Ayush going to do? He's going to add both of these numbers and he's going to send it across as 30. So right now, Reed has a number 30, it has 25. So the fun fact here is, even Harsha only has access to 25 and 30. Can you make out what's been used here to kind of get that number? Absolutely not. But that is the very fun fact about here, is it's not at all visible to Harsha. It's not going to be able to figure out what it is. And now what's going to happen is, this 30, he's going to add it with his own private key again. So what's going to happen is, no, cut it. It's going to add 30, and this is going to be 35. And now what's going to happen is, Ayush is also going to be adding 25 plus 10, which is his own private key. And what happened now? Both of these guys ended up with the same number. It's almost like magic. And the fun fact is, Harsha, who's sitting in the middle, is now a very sad person because he has access to none of his data. And now, any single conversation, if Reed wants to say hello, like she'll encrypt it with 35, the encryption key. He'll send it across, and then you are going to decrypt it with 35 again, which makes it perfect because no one's going to listen into this data. It's totally secure. So TLDR, this is what happens every day when you log on to any sort of website on the internet also. Absolutely any single website, you go log on to any bank portal, this is what happens. So then we come along to something that is in the name itself. If you guys know, the name is zkTLS. So now you guys understood what this algorithm is, right? How people communicate from A to B, right? Without showing anybody in the middle. But now let's talk about what TLS actually is. So whenever you type something and whenever you copy, all of you have copy pasted a link, right? You've always noted that there's an HTTPS in the link. There's always going to be that, right? So that's kind of the security layer, which makes sure that no one is actually listening to it, listening to the conversation, and it also makes sure that it also two things. It is the privacy. It makes sure that none of them are listening to it. It also makes sure that there's also integrity to the data that's coming in. So what does integrity mean here is, are you actually communicating with the right bank.com? Because you've also, if you guys, 100% of you guys have received scam emails from people like, hey, this is bank.com, come log in, we'll get you a credit card now. but that has turned out to be a scam. People lose a lot of money there. So TLS kind of make sure that you actually are communicating in the right website, and I'm going to show you how that's done as well. So let's take your example. Sir. You are on the Bumble. You're on the Bumble website. So what's going to happen is this happens in milliseconds, by the way. So the second you press X, like the second you press Enter, it's already done. So let's kind of dive into what happens in detail. So what's going to happen, like ideally, is whenever a student is going to send like a request, going to click on the link. What's going to happen is he's going to say a hello to Bumble, and then Bumble is going to respond back with a hello as well. So this is like a normal session. So along with the Bumble hello, Bumble is also going to come and give some certificates as well. So what are these certificates, right? Why does Bumble have to come back with certificates? Certificate is Bumble's way of saying like, hey, hi, I'm legit. Here are my SSL certificates. Here's my validity of the certificates. I'm actually the owner. I am the owner of the code base. I can push anything I want to, which kind of makes sense because only if a Bumble developer can push a code sense, that means that they'll have a certificate as well. So now Bumble is going to respond back with a hello and a certificate as well. To which Sunil is now going to be like, okay, this guy is kind of correct and who I'm going to be talking to. And then what's going to happen is, right here is where this process kind of comes into play. So right now they're going to do this asymmetric key exchange. They're going to make sure that they both have a key that they can now kind of transact with. So this process, this handshake that's been happening right now is what happens across every single website that you kind of tap into. This is how you make sure that you are interacting with the right website, and it's also how you make sure that nobody in the middle is actually doing anything as well. So, and that is the only job of TLS as well. So, do you guys have any doubts up until now? All good? Now I'm going to tell you guys. So this TLS is the fundamental technology that we are building our stack on as well, which is why the term zkTLS also came into play. So now I'm going to show you guys kind of 3 models of how zkTLS works in general. So one method is obviously you have a server, and what happens is every single so he'll send a request, and they'll come back with a response. All of this is going to be executed in something called as a TEE. So what is a TEE? It's a trusted executive environment. So think of somebody like Intel. Intel has something, a TEE called as SGX. So what you're basically doing there is you're trusting Intel to tell you that this data that's coming from your bank.com is actually coming from bank.com. So you're trusting like a certified third-party authority there that hey, this is going to be the right data, and I'm just going to trust you full-heartedly. But the problem with that is, since it's just in one place, there's been a lot of hacks, been a lot of exploits here, which is one of the reasons why we did not go with the TEE as of now. And then comes along a much more complex architecture, which is more so called as an MPC architecture. So what happens in an MPC is the same request response they come back, but every time something comes back, the client, on the other hand, is going to communicate with somebody. It's going to communicate with somebody called as a node. So there's going to be all this back and forth that's going to be happening. At least 2 modes of communication that's going to be happening between them. Every time there's a request sent, every time there's a response sent. So if you just take a look at this, so this is just for one request, and then you would have to make another communication. So if you just take a look at this, you see how big of a process this is. So zero knowledge proofs inherently are pretty hard to run on, it's very time consuming. So even for us, it took us, last year if you were to talk to me, I would say that our proofs generated 30 seconds, which was a miracle actually at that time, because everybody else, every research paper was doing it in 5 minutes, 10 minutes, 15 minutes to do some small bites of data. So imagine that in an MPC now. So you have to do all of this in a small amount of time, which is again why we didn't want to go with an MPC model. Now I'm going to come to what we do at Viking Protocol is, so you have A and B. So what we are doing here is we are introducing somebody called as an attester. So this person is actually pretty blind. I'll tell you why he's blind as well. So whenever there's a request sent, right? Whenever there's a request sent, what the attester would the only thing the attester is going to see is the encrypted request. So the user is going to send some encrypted request, it's going to go back to the server is going to come back, and it's going to be a response. So this A to B and B to A connection, right now there's a middleman in the middle as well, that's only seeing this encrypted kind of traffic that's coming into play. And now what happens after this encrypted traffic kind of comes into play is, so now you know that, see, you know the attester has now seen, like he knows that he calculates two things essentially. He makes sure that the TLS is already done, he makes sure that the certificates are all there, it's all secure, that you're communicating with the right website. He also makes sure that the path that's taken by the server to the attester is also correct. Because if you take a look at the internet, like the internet is not at all, like even though I say like A to B, B to C, B to A, it's actually A to B, like a lot of routers. It's like a very big dark forest that you kind of have to go through to kind of reach a point, which is exactly why like it is so crucial that you pinpoint each and every single like location, like router that you're tapping into, which is what the attester kind of sees and make sure that you're communicating with the right website. So whatever the MPC has done through all of these like huge like bidirectional flows are now being done in a single step by the attester now. And right now, what's going to happen is in our reclaim SDK, so we have an SDK. So our SDK is essentially a web view. So if you guys might ask like why can't we put the attester like in a normal Chrome browser, is because they don't allow that, which is why we built out a web view that kind of allows you to have an attester in the middle. Now what's going to happen is, so like okay Ayush, you wanna get access to Uber data. So you're going to send a request to Uber, your past ride history, and Uber is going to respond back also, here is the page. So now what does Ayush have? Ayush is already logged in, Ayush has access to all of the data, Ayush can see all of the data now. So now what we've built is, we have a zk circuit in our SDK. So this is an entirely custom circuit that our engineers, some of them are involved here, they built it off from scratch, it took a long time to build it. So this circuit, what it does is, so right now you have three inputs. The circuit is going to take in three inputs. One is obviously going to be the encrypted response, which is being sent over by the attester. Another one is going to be the decryption response, which Ayush is going to get after he logs into uber.com with his even a password. And then another one is going to be the JSON path and the X path. So I'm going to tell you why the JSON path and the X path is important. Because this solves a more even bigger problem. How many of you guys apply for a visa to come here? Yeah, you kind of have to give like any visa that you apply to, you kind of have to give your closing statements, you have to give all of this. If you take a look at your closing statement, you see absolutely every single thing that you've bought. But the only thing they actually give a shit about is the closing balance, which is inherently what they only care about. So why would you need to share all of this data just to kind of prove like one small thing there, right? So that is kind of fundamentally what zero knowledge also helps. It only helps you reveal the data that you actually need. So coming back to that, so we have a developer portal where you can kind of come, where Ayush can come as a developer for his application and come and be like, hey, I want my users to only generate a proof for their past ride history. Absolutely nothing else. I don't give a shit about anything else. This is the only thing I want to do. And that is what goes into as a JSON path. It's more of like a path that's taken by the circuit to kind of check and see where it's going to be. So now, along with all of this, what's going to happen? So Ayush already has like all of his data written down here. Now what the zero knowledge proof is going to do? It's going to redact all of this out and only reveal what needs to be there. So right now there's going to be like there's going to be a good transcript of only Ayush's campus. Who's coming, Hasha? Okay. So now what we do with this kind of transcript is we kind of send it over across to our attester again. Now our attester again like comes into play here and he verifies whether hey, this is the actual data being shared by the user again, and he sends it across to whatever third-party application it is. So TLDR, our proxy only sees the encrypted traffic that's going from A to B and comes back B to A. There's a small zk circuit inside our SDK which you kind of open as an app clip. which kind of creates a proof of whatever data it is that you want to share, and it shares it with anybody out there. So this is the reason why we've gone on with the proxy model. And if you kind of look at any of the competitors that are doing it out there as well, one big thing is obviously going to be the time it's going to be taking to generate a proof. Because if you're somebody that's building a consumer app, like, so you know, like a user having to spend more than 30 seconds on a flow itself is a very bad UX. People drop off instantly. So that's one problem, that's one big problem with the MPC model. But with the proxy, we're able to do proofs of even large data in under 4 to 5 seconds. So any of the data that you're actually sharing, you can actually generate a proof for it in under 5 seconds, which is not possible with the game solutions out there. And yep, that is kind of how we work. Now, just like how a normal teacher would ask you questions, I'm also going to ask you questions, make sure that you have actually learned. But before that, I'm going to give you one chance to ask me any question, any doubt that you have. I'm going to be asking you questions on what was the Caesar cipher that we talked about, what is zkTLS, what is the server. Like, I'm going to make you guys come here and draw. I'm kidding, but you have one chance.
Is there going to be a quiz?
Yeah, this is the quiz. I'm not going to ask you a quiz, man. You know more than me. I'm like the most non-technical person here. Okay. Am I good to ask questions?
Yeah.
Okay. I like how everybody's here. I'm just joking. I'm not going to do it. But if you guys actually do have doubts, I'm super happy to kind of answer them. So all of this is, I know it's very technical, but I know a lot of you guys also don't give a shit about it being a lot technical as well. Which is why I'm going to move on to the cool part of it as well, which is going to be what can you build with it right now, what can you do right now. So I'm just going to go on to the next part of the session. So where is the AI in all of this, right? So I previously said in the slide here that I want to call it AI-TLS and not zkTLS. Anything that's scalable right now, you need to do by AI, because you do every single task that you do that's either monotonous or repetitive, you get your AI involved in this. So where is the AI in all of this is a very good question. So we have a provider marketplace in production. So what is a provider marketplace? Is essentially a marketplace where you can just come right now and get access to all of this data. So for example, Sunil, you're building a dating app, right? So you can literally come to our application and get data from Bumble. Like you can build out a provider where users can share their data from Bumble, from Tinder, from any dating app that's out there. If you want to do a vampire attack, for example, Ayush from Aptos, they're building something called as Move Club, which is like a bounty platform for Aptos. So see, for them, even for retention, for people to kind of come and be on that platform, you need to incentivize the users to, and not just limit them to that application itself. Because if you take a look at what LinkedIn is doing, you have all those connections there. You have all those connections there, but no means can get it out of there. So even if you find a better alternative application, since all of the data is in one place, like you really can't do anything. Which is why even I was talking to Ayush about it as well. Like you can use like zkTLS to kind of bring a builder's reputation on chain. Like you can literally have somebody's GitHub score, like how well are they performing in Move, which is what the programming language you guys use. You can also do like lead code challenges, like lead code, like everybody does DSA when you do coding. So you can like maybe host like a competition where whoever has the most amount of streaks get like $100 like a week, and kind of keep everybody engaged onto that platform. So that is also something that you guys can do. You can just come to our marketplace and also like just kind of figure it out, like whatever you need. So this is just a few of it. We have almost 2,000 in production right now. Now I'm going to tell you like why there's AI in this. So I'll tell you how the competitors are doing it, and I'll tell you how we are doing it. I'm not going to shit on everybody, but I'll even like this tech is so good. Yeah.
When you said marketplace,
Yeah.
it means that we can use these
Yep.
tools after paying.
Yep. Essentially, yes. We are also, so I'll come back to that. So if you are using our version of zkTLS, like see, we are already sitting here, like we have an engineering team, like entire 30 people of engineering team maintaining the entire infrastructure, then you would need to be paying us to use any of these. But we are open sourced. So which means that you can actually just go forth the code and just literally run it yourself as well, and still have access to absolutely everything that's here as well.
but this brings my go-to-market seconds from weeks to few hours.
Hmm?
It brings my go-to-market strategy from weeks to few hours.
Absolutely. Yep. So, and I'll tell you the beauty of this as well. So, even us, like a year ago, like even I was not there, these guys were there. You know how hard it is to make something like this. You can have to sit and code for each and every single website that's out there. So for Twitter, you have to spend at least a day or two, minimum, right? Minimum, weeks. You have to spend weeks to build one thing. And the fun fact is, some of these websites, they're fucked up. What they do is, most of them are server-side rendered. So what they'll do is, if the developers find it a little fun, they push out a change. And when that change happens, what happens to our 2 weeks of effort? Gone. Like, you have to rewrite the entire thing again. So what we have done is, we're the only ones doing this. We have a tool.
Hello.
Who's ordering food? Everybody's chilling. I love it, I love it. So what we have done is,
Just a fun question.
one question, ask me sir.
I have a girlfriend who likes when I order legal things.
Got it.
And I want to prove to her that I am going by your advice. I just ordered a particular legal item
Yep.
via Swiggy,
Yep.
and I've just kept it in
okay.
front of me.
Yep.
Can I prove it via that I can show her Swiggy that I ordered this?
Yes sir, it will look like a masked Swiggy. It would show your entire profile, but just the part, it would mask everything out. It would be like a blurred image. But just the part that you want to tell her, that will be the only thing that will be. So the only thing she'll see is a blurred, and then in the middle will be like vegan ordered from your place actually.
So basically, I can use this zkTLS service like a much data-rich emoji for my girlfriend.
100%.
I'm going to implement it.
Oh, lovely. Love to see it. So coming back to why 100% why we are the best here is because we have a developer portal. So what a developer portal allows you to do is, it allows anybody to come and make this in under 5 minutes. And I'll tell you why I say anybody. Because as much as technical as I got here, I'm not a technical person. I'm a marketer for a claim protocol, and I do growth as well. So, but every video that you see out there, like every technical video that you see out there, it's probably done by me. And it's done by me just alone. Like, I can sit in a room right now and I can make it in 5 minutes. I can call any one of you right now and be like, hey dude, can you make one? And it's so easy because that's where we implemented AI. So all you have to do is you have an app, like, so just for a developer, since you're a developer, you need a developer portal app that we already have in the Play, like App Store and Play Store. You download it, you go to whatever website it is that you want to get data from. And this developer portal, what it's going to do, it's automatically going to capture every single data point that's going to be relevant to you. So for Sunil's example, it's going to be the last food that he ordered, which is, it's going to auto-select this. So it's going to be like last order that's captured. So all you do is you click on it, you click next, and you're done. You're testing the provider in like 3 minutes. Swiggy takes 3 minutes if you are like, if you're already like a developer. For somebody non-developer as well, it takes like maximum 5 minutes as well. So that's one place where we have implemented AI as well. And another cool thing that we're trying to do is, so do you guys know how expensive background verification is for academic credentials? Do you know, Samurai?
Very expensive.
Very expensive. It's like, if you just go onto like Google right now, it'll tell you $150, $200.